recently gave birth to this service. It's a new service. And yeah, so the implemented solution actually looks something like you just count the cores in RAM from placements and the number of instances in the server group members from the Nova API DB. Operator highlights around this feature would be that it's an opt-in way of counting quota. So by default, you would still use the legacy way, which is going through all the cells and aggregating the results. Of course, the cells are targeted in parallel, so it's a little bit performance efficient, of course. But if you're using placement, then you have to set the count usage from placement to true in the deployment specifically, in which case Nova will start using placement to count quotas, to count resources. And I would just like to point out that there are a couple of online data migrations that you have to run before you opt in into this method of counting quotas. Otherwise, it'll automatically fall back to the legacy way, which is looping through all the cells. So some of the other behavioral changes that we have in this way of counting quotas when compared to the traditional way is that I talked about cell 0, the special cell where you have all your error instances in. Today when we count quotas, we also count the cores and RAM of those instances. But if you start using placement, we will not be counting the cores and RAM for the error instances anymore. And the second point is about the resize. If you're doing a resize, in the current way of counting quotas, you only count the new flavor. But if you're using placement, then it's unfortunately a sum of the old and the new flavor. We're trying to work on this to just improve this feature, so it will not be a problem anymore. But right now, if you use this new method, it's yeah, you're going to be counting more resources. A limitation that I would like to mention here is it's an edge limitation. If you're a deployment that is running multiple Novas with the same placement service, since placement today doesn't have a way of modeling which Nova or which partition of the deployment that the provider belongs to. Like, for instance, there's no way of saying that I belong to Nova A or Nova B. So if you're using the same placement to count quotas, it's probably not a good solution to use placement to count quotas in that case. So that's it from me about handling down cells feature. Matt will take it from here.
Thanks. So as long as we've been talking about CellsV2 and sort of re-architecting how cells works in Nova, we've talked about the ability to, once we have this flat architecture for cells, we can do cross-cell migration, which is something we didn't support with CellsV1. If the silly train graphic doesn't make it clear, this is still under development in the train libraries. This is something that I've been working on since Stein, so probably 6 to 8 months now. For this talk, I'm going to focus primarily on a single use case and just sort of go over the design. There's many ways you could chart a deployment for cells. The one I'm going to focus on here is hardware generation. So I know that CERN does this. I know Huawei Public Cloud does this. You get new hardware in at certain times, and you would put it in a cell. And then when that hardware expires and you need to phase it out, you need to drain the old cell and get users onto your new cells. Obviously, you could do this today with multiple regions. You can do this with multiple cells today by creating snapshots. And actually, that's sort of the documented way in OpenStack to move servers across regions is just creating a snapshot and then creating it in the new region. You could do that with cells too. The problem is you potentially lose ports and volumes for that. You need to recreate those depending on how the server was created. You lose the UUID on the server. And it's also just more disruptive, and the user, they can control to some extent, but it would be nice if we could just naturally do this across cells the way that a user does a traditional resize. And also with doing this, a deployment can provide new flavors, or they can just give a timeline to the user to say, okay, you're in an old cell, we're going to start draining this thing, you've got to a deadline, and then you need to move your stuff, and then the user can do it on their own schedule. So getting a bit into the overview for cross-cell resize, the main thing that we wanted to do is keep it as transparent to the user as possible that they're getting resized across the cell, but they don't know that that's actually happening. So they don't know if they're getting resized within a cell or across the cell. So the biggest thing here is that the user flow, the end user flow from the REST API is the same. The state transition is the same. In the Queens release, we added the ability to target a host during a cold migration. So an admin can target a specific host and the scheduler would validate it. That's also going to be supported with cross-cell resize. So an admin that is trying to drain an old cell, they can specify a target host in another cell, and that will still get validated by the scheduler. One of the differences with the cross-cell resize compared to traditional resize is that there's actually needs to be orchestration at the what we call the top. So that's really the control service. So what we sometimes refer to as superconductor is just a normal conductor service, but it's running at the top layer of the topology, and it manages all of the different, it has access to the API database, and it can do things with the different cells. So with cross-cell resize, it's actually the conductor that's going to be coordinating how the resize works instead of the computes doing RPC asynchronous casts to each other. But with cross-cell resize, we still will do target host validation. So the flow to get hosts from the scheduler will get validated in the target cell. We'll try to make sure that ports and volumes still work when they actually go to the target host. And if that fails, we'll go into a reschedule loop like we have today. Now, since we're doing things across two different databases, we'll actually have, during the resize, 2 copies of the instance and its related records in different cells. And as Surya said, when you're listing records out of the API is actually iterating the cells to gather results and return them. So if you have 2 copies of something in the API, we need to know which one we should return, because there's one that's more active than the other. So we're just going to be adding a simple hidden field. This is something that the user can't get access to or anything, but this is just sort of internal metadata for tracking which of the copies of the instance is the most active. An assumption with cross-cell resize is that there's no communication between hosts and different cells. So you don't have shared storage, you don't have SSH. So we have to be able to get the root disk out of the source cell, and for that we're going to use glance to create a snapshot. So similar to how you can move things across regions, we're just going to do this within Nova, and it's actually extremely similar to the way that the shelve offload feature works, shelve and unshelve, which creates a snapshot. This is only for servers that are not backed by volumes. For something that is volume backed, we assume that Cinder is global or will have connection across the cells that you would be migrating. We are going to be adding a new policy rule to control this, and by default this will be disabled for all users. This will allow you to roll it out. In your deployment, you could, for example, enable it for admins. If you just want to start making sure that this will actually work for you, you could enable it for a QA team. For example, maybe you only want to enable it for admins so they can do cold migrations before enabling non-admin users to do this. And finally, there's a new scheduler where being added, which will default to resize within the same cell that an instance is already in, because that's what we're used to. In the Stein release, though, we added the ability to Nova to override. So if you're familiar with wires today, it's basically a global configuration. If you configure wires, they affect everything at a global level. But in the Stein release, we added the ability to override weights on a per aggregate basis. So going back to the hardware generation example, if you left the cross-cell wire at the default value, which would be to keep resizes within the same cell, anything that's in a new cell that you don't want to move, you just don't touch anything. But if you have an old cell that you want to drain naturally by having just users do resizes, you can create an aggregate on the old cell, override the weights, and say, okay, if anything tries to resize in this old cell, then I want it to prefer trying to move. If there's another host in another cell, it will automatically try to move it. So here I just wanted to go through, not in a great level of detail, but pointing out that this is the traditional flow, and it's basically once the control services on the left pick a target host, they sort of just cast off, and then the computes do the rest of the operation between themselves. And it's really a preparation on the target, resize on the source, and then finish on the target. And on the source host, what we do is we power off the instance, and then we transfer the disks over to the target. And on the finish step on the target, then we connect volumes, set up networking, and start up the instance again. As I said, the goal with cross-cell resize is to make us as transparent as possible and as similar to traditional resize as possible. So the end user doesn't care how this is actually implemented. But within the Nova development team, it's very important that somebody that's maintaining this code or contributing to Nova doesn't get just totally confused about how traditional resize works and normal resize, or cross-cell resize works. The big difference is the orchestration that I mentioned before. So in this case, Conductor is doing the orchestration at the top because it has access to all the cells in their databases. The cell itself should not actually have access to the API database. This is why we don't have the compute cells communicating between each other to do this orchestration. The tasks in the Conductor is essentially just a task flow. This is all synchronous. So the first thing you have to do, obviously, is create a copy of the instance and all its records in the target cell database. But once we get that done with that, it's essentially the same thing as traditional resize, where we prepare on the target, create the snapshot on the source, and then we finish on the target. And then conductor is also in charge of flipping that hidden field and just sort of managing some of the state in the API database. And I don't have a slide for this, but there's also the confirm and revert steps with resize. That's also extremely similar between cross-cell resize and traditional resize. I would say one big difference is, if you're familiar with Nova, we sort of like to pack rat and hoard all of the data in the cells, and we never delete anything. So that's the soft delete thing. Once you delete a record, it's not actually deleted until you archive it or purge it. With cross-cell resize, we'll actually be hard deleting resources in the cells, but because we have a copy in either place, you're not really losing anything. But for example, when you do confirm a resize, then we'll actually hard delete the instance records out of the source cell database. I won't get into great detail about this. This is just sort of a table of the comparison between the traditional and cross-cell. One thing to point out, that when I was actually working on this, I didn't know this, but I was kind of surprised that during a normal resize today, we actually block pretty long until we actually cast off to the computes, which I was not aware of until I started working on this. We fixed this for live migration, so live migration just casts off from the API a lot faster. But so for cross-cell, we're actually going to cast off sooner. So as soon as the API casts off to conductor, that's it. Either way, the user gets a 202 response. So again, to the user, it's transparent. There are some limitations and known issues with cross-cell resize, but they're not restricted to cross-cell resize, I would say. Personality files, also known as file injection, was deprecated several releases ago. People can still use it if they want, since it's based on a micro version. But personality files are not going to be retained across the cross-cell resize. And I will point out that during a traditional resize today, if you're not using config drive, you're already losing your personality files, because we don't persist these things. And if you're not using config drive at all, and your server gets moved ever, like during an evacuate or a shell, for example, you already lose these things because the metadata API can't serve them. The config drive will get rebuilt in the target cell. We're not transferring that over because we don't have SSH or shared storage between the hosts. But again, if you're not using personality files, this shouldn't be a big deal. There is a periodic task in the compute that will you can configure this to automatically confirm a resize. Some deployments might set this to like 1 second, so users don't actually get the option to confirm or revert. It just automatically happens for them. This may or may not work depending on how you have isolated the cell from the API database. Like I said before, we don't really want the cells having access to the API database, because if you get out of there, you have access to the deployment. But there are still gaps in CellsV2 support so that we can totally decouple the API from the cells. So this may or may not work depending on how you do your deployment. Instance actions, if people are familiar with these, they're just kind of the debug thing. It's kind of like an audit log. Instance actions will be the same. The actual actions themselves will be the same, but the events are based on the methods that get used during the operation. And the events, since this is all new code, the events are going to be different. But by default, the events are actually only exposed to admins. So this is, again, just sort of a debug thing. This is just, FYI, if people are aware and use and rely on instance actions and events. And finally, the notification source may change depending, again, on how you configure your notification queues. If they're per cell, as we're doing things across the different cells, you'd be getting notifications from different sources. Finally, I will ask for reviews from anybody that's interested in this. When I wrote this slide, I have 47 open patches. This is probably the biggest. I think I've been working on Nova for over 6 years, and this is probably the biggest patch series of code that I've ever worked on. So if you're interested in this, please do some reviews. Probably more importantly is doing manual testing. I do have a pretty robust set of functional tests in Nova, but with those functional tests, we have to stub out things like Cinder and Neutron and Glance. And what I would really kind of need is people just deploying this, and you can even do this in a DevStack multi-node environment. But fault injection is going to kind of be a big thing that I need testing with. And I've got a patch up for I think this is actually approved this morning. We will finally have a multi-cell job in the gate queue, so using DevStack. So what we don't have with the functional tests in Nova, we will actually have in the gate. Something we probably should have had since the Pike release. And that was it for cross-cell resize. Any questions?
So my question is actually for you. It was around when you had stated before that if you've got a single placement API with reporting capacity, you said like RAM metrics, et cetera, et cetera, et cetera. Would that be a good use case for like placement aggregates instead? So that way you can actually still use one placement API instead of like having to use individual placement APIs for each cell?
Can you just repeat that? I'm not sure I got the full question.
Placement aggregates are not like Nova host aggregates. So placement aggregates are just a grouping mechanism of resource providers. The issue with one placement for multiple Nova deployments is placement doesn't support, it doesn't have like a concept of a sharding key. So this is like an edge, what we've been referring to as like the medium-sized edge site. If you've got multiple Novas and they're talking to a single placement, they're reporting all of the resources into placement, and the accounting for the project would be incorrect as far as quota is concerned.
Yeah, I think what you're asking is could you use placement aggregates to partition placement? You could. That was one of the proposals for how to deal with the lack of partitioning, is to have the operators set up placement aggregates, and then when we do the quota request, if we were able to pass an aggregate, you might need to say only count for this aggregate. That would be possible, but it would require like either operator setup, or we'd have to provide some kind of tool for syncing or something to do it. So we kind of went away from that idea, but you could do that. Thanks.
Yeah.
So if I understood correctly, the main transition here was to use the conductor.
Come to the mic. Come to the mic. Nobody can hear you.
Oh, or I can repeat it.
Okay, so if I understood correctly, the main changes here is basically use the conductor to enable the cross-cell resize as the orchestrator, similar to the light migration.
Sort of.
Sort of. Is there a plan to unify the resize in the same cell and the cross-cell resize to the same flow?
So when I initially did, I had a proof of concept for this 7 months ago, which was based on using shelve. And that very quickly got very ugly because we had to sort of put all this resize logic in the shelve code, and we ditched that. So one of the ideas with making cross-cell resizes similar to normal resize is that we could eventually potentially do something like this.
The other way around.
Or sorry, yeah, but unify them, essentially.
Yeah, exactly.
Because another case would be if you don't want to set up SSH between computes. You don't have multiple cells, but you don't want to set up SSH between all the computes. If we could do something like this where you're just doing snapshots, but between hosts in the same cell. So it's not something that we're working on now, but the way that it's been designed is that potentially we could do that later.
Okay.
One more question. So for the down cells, it looks like you're using a timeout. For example, as a user, if I wait for 60 seconds, I mean, obviously I can change that timeout as an operator. But from a user's perspective, if I don't see results in 10 seconds, I'm going to do a Control-C and make a ticket with my OpenStack team. Is there like a periodic task that can do like check for down cells and mark somewhere that it's down, so it's quicker instead of like waiting for these timeouts? Maybe the code is already there, I don't know, but just a question.
It's a good question, but we don't have any periodic tasks that checks for down cells. But I also think that this is not something that would happen every day in the deployment. It's a very corner case scenario. But yeah, and also regarding the timeouts that the users might wait for, well, from experience, if you have a really large deployment with a lot of instances, the listing right now also takes several seconds, at least for us at CERN. Even when you load it on Horizon, it does take some time. So I think it depends on how you set the operator sets the options, I guess.
Yeah, I mean, I just thought about periodic tasks, setting down cells makes.
Yeah, I don't know. I guess it's a question of overhead versus the actual, I don't know.
And if this is something that like you're dealing with quite a bit. I mean, obviously we could do some sort of caching in the API to say, okay, if I've hit cell 5 is, after 10 times it's down, then I cache it and I don't want to check it anymore. And then maybe we, every, I don't know, 15 minutes or 20 minutes or something, you invalidate the cache and try again or something. So those are things we can do. It's just nobody's really come up and said, I need that kind of thing,
I'm just wondering, how do you do the network part for the two cells? Can they communicate with each other?
So we're using the port binding API in Neutron that was added in, I think it was the Queens, or maybe the Rocky release. That's how we validate that the port should work on the target cell as that prep step I mentioned. So we try to create the port binding for the destination early, and if that fails, then we don't use that host and we go to the next host. But as far as when we get to the target host, then we're just doing normal port binding. But again, it's going to be very deployment specific. So this is kind of where I need people that are going to be using this to be doing manual testing for their deployment, saying this is how my networking is set up, and it will or will not work. And then we can refine the solution based on that.
Okay, thanks.
Yep.
Hi, thanks for this. So I'm a little new to how Nova is set up, so I just have a quick couple questions. The placement service or database, does that sit in the API database?
It's a control service.
It's a control service.
Yeah.
Okay, so if how far can I extend this cells concept with the single placement database? How does it affect performance if I, let's say, extended cells outside of a specific data center, but I still talk to the same placement database?
It works pretty well. We do that at CERN. We have around 70 cells and one placement. We have a lot of workers, but we've had a couple of issues with the scaling and the number of requests that you hit placement with. But we've worked on it for a couple of releases, and right now in Rocky, I think it's pretty stable.
Yeah, there was if you want to look up, I think it was at the Vancouver Summit. So CERN did a couple of talks on when they upgraded it to CellsV2, and some of the scaling issues they hit, and one of them was placement wasn't keeping up with all of because the computes get very chatty with placement because they're reporting inventory and everything. And it was just a matter of, I think, scaling out the placement service. And then I think Belmiro said that solved the problem. So placement is designed to be very horizontally scalable. It's just an API in a database. And is there a show of hands of how many people actually are running cells? I know CERN is. Are you guys? GoDaddy. Oh, okay. But CellsV1?
V1 and V2, both.
Okay. Because I haven't been up to date on all of that so far. Since Chris isn't here, I don't recognize any of the GoDaddy people anymore. Anybody thinking about moving to multiple cells? Okay, cool. Yeah, I know some people have been waiting for this down cells resiliency stuff to get baked in a bit before actually taking that on, so. All right, anything else?
Yeah, just to clarify, it's just kind of made its way to OOO, which is a requirement for me and everybody down there to be able to use it. So
yeah,
it's something I've been very desperately wanting. It's just, now people are going to be putting it on in. As far as the reviews, you said you have a queue of about 50 some odd reviews out there. Is there a community of people that you can rely on to review those, or is it really something that this is very, very specialized and you need to develop the knowledge on?
I've tried to build it up as much as possible to split things out so that the things that apply to everything in Nova go towards the bottom, and then the more specialized stuff builds on top of that. Not really. There are a couple of special, but like the instance hidden one is a little bit special. There's some of the database stuff that's a little bit specialized, but really it's not super special as far as, it's not super advanced Nova stuff. And that's in part because of the flat architecture with CellsV2. If we were doing this with CellsV1, there would be like one person that could review it. But again, that's why we never sort of did it with CellsV1. It was very complicated. Plus we wanted to kill CellsV1.
I have just a curiosity mainly. So now that the resize is actually getting out of a cell, Is there any plan to have actually kind of live migration also following this approach?
That is, eventually, yeah, that's an idea. I know Huawei wants that, obviously. Huawei Public Cloud does a lot of live migration to rebalance and utilize resources. It's just not something that we picked resize first because this is the thing that non-admin users can aid in themselves. So.
Thanks.
Yep. The networking is going to be funky with live migration, I imagine. So. Okay, I think we're at time. Thanks.